Hello and welcome to the second half of college algebra. My name is Gregory Carlson. Chapter 4 is going to look at inverse functions as well as some special types of functions, and then talk about exponential and logarithmic functions, which are really cool. So let's get started. To review, what is a function? A function is a mathematical rule, oftentimes an equation, which takes a group of inputs called the domain and maps them or sends them to a bunch of outputs, which are called the range. And what makes a function special? What makes it a function special is that no one input goes to two different outputs. Every input only goes to one output. Now, there's a special group of functions called injective functions, or they're sometimes called one-to-one. And so what makes so we already have a function where each input only goes to one output, but what makes an injective function special is that no two or more inputs go to the same output. So let me show you what I'm talking about. Here is an example, example one of a one-to-one function. So say I have four inputs, let's just call them 1, 2, 3, 4. And say I have some outputs, just say 5, 6, 7, and 8. If each one of these only goes to a unique output, we say that the function is one-to-one. So even though that these are crossing, that's okay. Every input is only going to one output, and that makes it one-to-one. So let's look at an example of a non-injective function. So say again, I have a bunch of inputs, and say I have some outputs. Okay, 1 goes to 5, 2 goes to 6, 3 goes to 7, and 4 goes to 7. So my question is this a function? Is example 2 a function? The answer is yes, because it's a function because every input is only going to one output. Okay, so that's good. It's not a function if one of these branches and goes to two outputs. But do you see how 3 and 4 both go to the same output? So that means this is not an injective function. So example 1 is injective, or one-to-one, because every output only is paired with one input. But here, because we had two inputs going to the same output, this is not injective. And so, but it is still a function. Both of these are functions. Let's look at an example of what it looks like on a graph. So on a graph, you'll notice that to determine if something was a function, we used the vertical line test. Now we can use the horizontal line test to see if something is one-to-one. So let's look at an example of a function that is one-to-one, and that would be just a regular old line. So you should be able to see that this is going to be an injective function, because every time I have an input, it's going to go to a unique output. So this example is injective because every single input goes to a unique output. So what would be an example of something on a graph that's not injective? Well, check this out. This is the classic just regular old parabola. And you can see that we have two x values that go to the same y value. So just like here, when we had 3 and 4 both going to the same output, here I have -2 and 2 both going to the same y output. So this is not injective because two inputs are going to the same output. So you can see how we can figure this out with the horizontal line test. If you can draw a line through a graph that's horizontal that touches it in two places or more, then you know that it's not injective. However, if every time you draw a horizontal line through it, it only touches the graph at one place, then you know that it is injective. Notice again that both of these are functions. It's just that this is an injective function and this is not an injective function. So how can we tell if a function is injective or not injective? just by looking at the equation? Well, let's take a look. There is one thing we've already learned that can really help us here. Remember, the goal will be to see if there's two x values we can think of that will lead to the same y value. That's what we want. We want two different x's that go to the same y value. So can you remember something we've already learned in this class that will help us do that? Pause the video for a second to see if you can think about it. Look at these equations here. Do you have it? What do you notice about this function right here? It's even. One big clue that a function is not going to be injective is that it's even, because remember, an even function is when f of x is equal to f of negative x. And by definition, that's two x values going to the same y value. Do you see that? So if a function is even, it's automatically not going to be injective. However, truthfully, all you need to do is just find two x values that go to the same y, and then you're done. So check out this function right here. X squared plus y squared equals 10. I can tell that that's not going to be injective because the x is being squared. If you plug in -2 here or +2, okay, you're going to get y values that are repeated. If you think about this on a graph, it's a circle with radius square root of 10, as we've already learned, and you can see that this fails the horizontal line test, so it's not injective. Okay? How about this example? Y equals 2x plus 1. Well, every time I plug in an x value here, it's going to give me a different y value. There's no way that two x's can give me a different y. So it passes the horizontal line test just like this graph did. So this function is one-to-one. And remember, one-to-one means the same thing as injective. Okay? So that is one-to-one. What about y equals x squared? Again, you can see that this is an even function, so therefore it's not one-to-one by default. You can pick any pair of values, like 5 and -5, that are going to go to the same y value, so therefore it's not one-to-one. We do not want two inputs going to the same output. Hopefully this is making sense. And finally, what about y equals x to the 4 plus x squared? You can see that both of these are even, and so that means the function is even, so it's not one-to-one. Oops, not one-to-one. And finally, the last one, again, you can see that our only x value is to the 4th power. So that means if you plug in a negative and a positive of the same number, you're going to get the same values right here. So this is not one-to-one because it's an even function. Notice, by the way, that just as one last example, just because a function is odd doesn't necessarily make it even. For example, this function right here is a cubic function where the highest power would be to the 3rd. But you can see that this function is not going to be one-to-one because we have two different x values, in this case going to 3. 3 different x values going to the same y. So just because a function kind of looks like it might be odd does not necessarily mean that it's not one-to-one. What you're looking for is just any function where multiple x's give you the same y. So hopefully a one-to-one or injective function makes sense. In the next section, we're going to look at inverse functions, and I will see you there.